This conference will now be recorded.
Sir, we couldn't hear you anything, sir.
Can you hear me, guys?
Now only we are hearing, sir.
Hello?
Yeah, sure. Yeah,
Yes, now you'll be able
we
to
can
hear.
hear.
Okay. Okay, so in last class, look, in last class, completely we have automated VPC creation. Okay, we created one VPC, two route tables, two subnets, one gateway, and we created one key file, security group, one instance, but everything we have hard coded. Okay, so if you want to reuse the script, we have to use variables. How to use variables in last class, I have told. Okay, so to continue from last class, let us go to this folder. This is our folder where we are writing our script, Terraform, Durgasoft to 6th December. So here, open Git Bash. From here, open Visual Studio Code. Okay, this is the variable file we have written in last class. Here we have defined these variables like VPC CADR, subnet CADRs, ports, subnet tags, subnet names, from whom. Okay. Now let us write scripting based on these variables. And let us create one more file here. This is variables vpc.tf. You can give any name, but extension must be .tf. Here. So this is a script that we have written in last class. Okay, this is for VPC creation. This is for gateway creation. Subnet 1, subnet 2, route table 1, route table 2, and these are the two route table associations, and this is key file creation and security group creation. So security group creation, we have opened 22 and 80 ports here, and finally we have created web server. Okay, now here everything is hard coded here. CADR block directly I have written here, and here in subnet 1 also directly I have hard coded everything, but this time by using variables we are going to do it. First let us create VPC. So while creating VPC, we are going to use variable spot. And in the place of CADR block, what I am going to write? I don't write value directly. Variable dot CADR block, VPC CADR. Okay, automatically it is popping up. See, because in variables in inputs.tf, we have defined VPC as VPC underscore CADR. That is why automatically it is popping up. And next thing is resource. Our next resource to be created is gateway. Okay, gateway creation. I don't use any variable part here because in gateway we don't need to change anything. Okay, so but it is going to refer. Okay, it will be connected to our VPC. VPC ID equal to AWS VPC underscore our VPC dot ID, and gateway name will be my gateway. Okay, so our next task is to create two subnets. one subnet for public, another subnet for private. Okay, let us do this activity. And I don't use the resource block for 2 times here. In yesterday's class, what I did, I have written these subnet blocks for 2 times, right? Okay, this is going to create subnet 1 and this is going to create subnet 2. But suppose I want to create 10 subnets. Okay, for 10 subnets, I cannot write a script like this here. This must be written in a efficient manner. Okay, very excellent manner. Okay, using variables. So for that, okay, so we have to use a Terraform meta argument called count. Okay, how to use the Terraform meta arguments. So there are documentation here. Let us see the documentation. Terraform meta argument count. Count is a meta argument which is going to execute a specific block for more than one time. And see, very simple example he has given here. Resource and resource type will be AWS underscore instance. Okay, so this is a resource name. Count equal to 4 means this particular block will be executed for 4 times. Creates 4 similar EC2 instances. And for every instance, AMI ID will be same, instance type will be same, and server name will be indexed like this here. Server 1, server 0, server 1, server 2, server 3, 0 to 3. Okay, so index value is going to give values from 0 to 3. Okay, here also in our script we are going to use count object, count meta argument. Okay, first let us take one and here I am going to change according to our requirement. Where is that script? VPC where's right? Here I am going to write, I don't write subnet 2, subnet 1. Here I am going to write subnets only. Subnets. And VPC ID will be same for everything. And here count, I am going to decide, I am going to write count. Here I am going to write count equal to, okay, length. Okay, length is another function which is going to give, okay, the length of a resource, the length of a variable. Okay, suppose in inputs.tf, here we have some values like subnet CADRs, subnet tags. Okay, and in subnet tags I can give something like this: default equal to, within double quotation I'm going to give public subnet comma private subnet. So these are the default values which does not accept any values from keyboard. When you are giving default value, it does not take anything from keyboard. Okay, if this becomes 0th value and if this is first value, that means subnet underscore tags of 0 equal to public subnet, subnet underscore tags of 1 equal to private subnet. Okay, this observation you have to make. Now here in variables.vpc, I am going to write length. Length is a function which is going to give length, which is going to give length of a array, length of a list. Okay, so here within double quotation I am going to give variable dot subnet tags. Okay, subnet tags is going to have 2 values, right? 2 values here. So this becomes, count becomes 2. Count becomes automatically 2. Sorry. Count becomes 2 here. And in the place of CADR block, I don't write like this here. Okay. Now this is what I have given in inputs.tf. subnet CIDRs, right? I am going to take subnet CIDRs of variable dot subnet underscore subnet CIDRs of this is what I can give count dot index, or simply you can write index. Here in the documentation how they have given index value, here count dot index we have to give count dot index. You can give count dot index, count dot index, and here tag value will be also same thing. Here I don't write directly like this. Here variable dot subnet underscore tags quotes, subnet tags of count dot index. This is the process. Okay, now this is going to create two subnets. First subnet will be subnets of 0, second subnet will be subnets of 1, and after this we have to create two route tables. Okay, so to create two route tables, see RT1 and RT2. Even you can write uh, here by using loops also. Okay, let us take this. Here I am going to write RTs, route tables. VPC ID will be same for everything, and here this will be count equal to length of variable dot subnet underscore tags. Okay, so here why I am giving tags, because anything can be given, but which must contain two values. Subnet names, and in the place of this one 0.0.0, route tables only. Let us do this. Okay. Because one route table must be attached to gateway, another route table must not be attached to gateway. So that is why we cannot write loops here. Copy this, paste it over here. RT1 and RT2. So our next task is a route table association. So to associate route table, we have written two blocks here. See here. One is A1, other one is A2. Okay. And let us do this activity. Copy. Paste it over here. But here we cannot write subnet 1 and subnet 2. Okay, here this is subnet of 0, and this is also subnets of 1. Subnets of 0 is public subnet. Okay, subnets of 1 means it is private subnet. So our next task is we have to create a security group. Okay, so here what is the pending here? Security group, right? Now here you can write exactly, take this. Okay, key file also. Key file name I am not changing. Okay, exactly I am keeping same key file name. Okay, the key file will be key for my Terraform. Okay, this is the key I am going to create, and let us create a security group. And to create security group, okay, I am going to take dynamic values here. And here in the place of 22, okay, I can write something like variable dot. Okay, and what are the variables that I have defined in inputs here? Ports, right? Ports of 0, ports of 1. Ports of 0 is 22, ports of 1 is 80. Okay, this is the default value. So you can also define two values here in the inputs. So here two ports, right? So you can define a default value also. Default equal to one is 22, other one is 80. 22 is 0, 80 is 1. Now here variable dot ports of 0, and this is also variable dot ports of 0. And here we have defined variable, right? From whom? Okay, you can write that part here. Variable dot from whom? This one. And here this is also from port equal to variable dot ports of 1. And this one also variable dot ports of 1. And in the place of 0.0.0 slash 0, you can write variable dot from whom. Okay, so finally you have to create a server. Okay, to create server already we know this. Okay, you can copy or you can write everything, no problem. But for the sake of time saving, okay, I am going to write everything, copy it. Associate public IP address, security groups, everything I have written over here. Okay. Now in the variables file, what it is going to take here? It is going to take VPC CIDR value, subnet CIDRs, port range it does not ask because we have given default values, right? And it will also ask subnet names. Okay, subnet names also you can give default values, no problem. Default equal to public subnet and private subnet. Now let us test syntax. Terraform validate. Take even subnets 17th line number. Okay, 77 and 85. 77. We have defined 2 times 85 also. 98. This is subnets of 0. Done. Okay. Now let us go and activate credentials. Now let us go to IAM, users, security credentials, activate. Now let us generate plan, Terraform plan. Okay, it is asking from whom. Okay, you have to give 0.0.0.0.0.0 /0 subnet CIDRs. So subnet CIDRs I can give 10.0.0.0 /24, sorry, 25, comma 10.0.0.0 slash, sorry, it is 128, 128 by 25. Close the brackets. It is a list, right? So list must be given like this. VPC CADR 10.0.0.0/24. What is that? Okay, so it is telling that don't give any commas. Let us try it once again. Zero dot zero dot zero dot zero /0 subnet CIDRs 0.0.0, sorry, 10.0.0.0 /25, 10.0.0.128 by 25. Close it and close the brackets. 10.0.0.0 /24. Okay, it is telling that it will create 11 resources. Now when you say Terraform apply, auto approve, again it is asking same thing, 0.0.0 /0 from whom, 10.0. We have to do double quotations, 10.0.0.0 /25, close quotation, and 10.0.0.128 by 25, close quotation, close brackets. VPC CADR 10.0.0 /24. Okay, now it is creating key file, everything it is creating. Subnets, Okay, 11 resources are created. So if you want to see the confirmation, you can say Terraform show. It is going to display information from state file, and this is the information that it has created. And if you want to know the confirmation, go into VPC. Your VPCs are using your main VPC is created here. Subnets. Two subnets are created, public subnet and private subnet. Route tables. Two route tables, private route table and public route table. And internet gateway. And security groups. SG from Terraform. Okay. So it is created with two rules. Two inbound rules. 22 and 80. 22 and 80. Here. Okay. Now. And server. If you want to see server, EC2. Server is also created. Web server. I did not give any tag names. Okay, you can give tag names also. Here you can give tags. M equal to server. Zero dot zero dot zero dot zero slash zero. 10 dot zero dot zero dot zero slash 25, comma 10 dot zero dot zero dot 128 by 25. 10 dot zero dot zero dot zero slash 24. Okay, it is missing something. Tags are not expected here. Did you mean define tags? Tags are tag. Okay. So I think tags must be given like this. Terraform, AWS EC2 instance. Tags must be given like this here. Okay, I am not going to give because we know how to give tags here within the resource block you can give. Okay, guys, is it clear? Is it the script becomes efficient when compared to last session's script? In the last session, everything we have hard coded, everything we have written within Terraform file only. But here this time I have written everything in the form of variables. Is a script reusable? Now can I use the same script for multiple environments? Okay, like dev environment, for a dev environment I can give 10 series. For QA I can give 192 series, or for prod I can give 172 series. Based on network range, can I give anything? And even you can give the image ID also from keyboard. Okay, because from environment to environment, the VM size will be changed. That is why you can even give the image ID from keyboard also. Is it okay, guys? Is everything clear?
Yes, sir.
Now, till this point, just we have created a virtual machine. But creating a virtual machine and we have to do some provisioning also. Once my VM is created, Terraform should log in into that VM and it has to do some provisioning script. It has to execute some script. Okay. Generally in provisioning script, we are going to write something like installing softwares. Okay. Installing OpenJDK, Apache 2, Nginx. Okay. These kind of servers we are going to create. Once my VMs are created, that is called as provisioning part. That is called as provisioning. So here provisioner block. So provisioners are nothing but okay, they are going to install some softwares once our resources, once our VMs are created. Okay, so here Terraform offers three types of provisioners here. These are used to execute or to provision some softwares once VMs are created. Terraform offers three types of provisioners. So what are the three types of provisioners? One is local EXEC. Second one is remote EXEC. Third one is file provisioner. And what is local EXEC? So local EXEC is a provisioner which we can use to execute some shell script on the machine where we are running Terraform. Okay. This is to execute. This is to execute script. Okay. Some script on the server where, okay, from where we run Terraform. And remote exec, it is what here? This is to execute some script, okay, on the resource. Okay, resource means here this is VM, virtual machine, that Terraform creates. Okay, so local exec, this is to execute some script on the same machine where from where you are running Terraform. And remote exec, this is completely different. Suppose here, and suppose this is a what, this is a system from where you are running Terraform, and this is a second system that Terraform is going to create. Okay, here this is a system, Terraform system. Okay, here when you write some script in local exec provisioner, that script will be executed here in this Terraform system. And this is a VM, this is a resource that Terraform is going to create. Okay, so when you write some script in a remote exec, okay, my Terraform is going to connect to this remote server, and there it is going to execute the script. Generally, script is for installing softwares. It can be any softwares like Tomcat, JBoss, okay, Nginx, IAS, any kind of softwares can be installed on a remote system. And then what is about file provisioner here? This is used to copy a file from the server. Okay, server means where we are running Terraform. To this is used to copy a file from the server from where we are running Terraform to the resource. Resource means which Terraform is going to create. Terraform creates servers, right? Okay, and the newly created server, if you want to copy a file, okay, you can use this file provisioner. Okay, suppose this is your system. So here I have some artifact. Assume that this is my build server as well as Terraform server. Okay, here my build server has executed. My build server has created an artifact. My build server has created an artifact. I want to copy this artifact into the server. Suppose this is a server. Okay, so which is running QA automated testing, and I want to copy this artifact from this server to this QA server. So then I can use file provisioner. Now let us see how to run remote exec, file local exec, everything. Now first let us look at Terraform remote exec. Terraform AWS remote exec. Now just have a look of this one. Now here we are creating a instance here. As a part of instance creation, okay, we are writing connection block. So connection block is used to connect to remote server. Okay, Terraform is going to connect to this remote server that it will create. Now to connect to the server, it needs some credentials, right? Username and password, or username or key file is also required. And host equal to self.public IP means it will connect to the server that it is going to create. And once the connection is created, so this is going to execute this script. Okay, so here inline script. So here itself, if you want to execute some script, we can write inline equal to, okay, the script to be executed. Now let us destroy our infrastructure, because everything we have done correctly. Destroy. What happened? What is it is expecting? As 24, right? 4 zeros. 0s only we are given. It is not destroying. This is CATL is not set. 0.0.0.0/0 10.0.0.0/25 10.0.0.128/25 10.0.0.0/24. Tags are not expected here. Okay, remove tags. Dot 0.0/0 in double quotation 10.0.0.0/25 10.0.0.128/25 close the bracket 10.0.0.0/24. Okay, so it is destroying everything. Okay, 11 resources are destroyed. Now we are going to create one more file. This is remote exec dot tf. Now let us take the script from VPC dot tf. This is AMI is same thing. Instance type T2 micro, subnet ID is not required here. We can remove subnet ID and key pair name you can give this one. And here in the place of VPC security group IDs, you can write simply security group IDs. Security groups, okay, equal to And first create a few security, one security group here. Okay, of course you can create security group here also, but I am creating a security group in console first. Security group, and this is my security group name, my SG 12th December for testing. So these are default VPC. So what are the rules I am adding here? One rule I am adding is 22 port number for everyone. And one more rule also I am adding, this is 80 for everyone. And click on create security group. This is a security group, right? Copy this. And let us give this security group. Okay. Okay, once it is done, next thing is we have to write connection block. Okay, in the connection block, what are the things we have to write? And here see, this is our examples. You can write simply this block, connection block. And here you can write output block also. In the output block, just we are printing the IP address of the server. The IP address of the server we are printing. Here file name can be anything. Security group. This is in double quotation you can write the security group name. And key file name also you can directly write like this. And you can omit this.
No, under file double quotes you missed it actually.
Which one?
Next to files. Close double quotes. Private key is equal to, yeah, this one, yeah.
What is the key file name I am going to give? One key file you have to create. Key pairs and create a key pair. This is 12th December. My key. And create PEM file. It is not PPK. Create key pair. And you can mention that key file here. Dot PEM. And here in the provisional block I am writing script for installing Nginx server. Okay, Nginx is a web server, or you can think of it is like a load balancer. Okay, in the place of Nginx you can write any server name like HTTPD, Apache 2, you can write anything. Okay, first it is going to create a server with these particulars. Okay, with the instance type associate equal to associate public IP address equal to 2, and key name equal to this is a key file, this is a key name. And so once my server is created, just a minute guys. Hello.
Yeah, okay, sir.
Okay, guys. Now your security group is my SG 12th December, and once my server is created, it will connect to the server. So to connect to the server, it need either private key or password. Okay, but direct giving password is not a correct option. Okay, we are giving private key. Okay, host equal to self.public IP. And after connecting to the server, it is going to execute this script. So by this script, it is going to execute nginx software, server software. So here this is output block, guys. So in the output block, what I am doing, we are displaying the value of public IP. Okay, public IP of the server. So here what is this, how I am displaying here? AWS instance is a resource type, and here this is web server, right? We have to write web server, not nginx. This is web server dot public IP. Public IP is an attribute. Okay. Now let us validate it. First, did I comment this? Yes. Terraform validate while calling private key. We have to give file up. Okay, actually file is a function, guys. File is a function which is going to return the content of the file. Okay, it is telling that AWS web server when calling. No file exists 12th December. My key. Okay. This is a key file I'm using.
And the locally the key file should be present, right? Not required.
What is it?
No, the .pem, the locally the key file should be present or not? No, not
Yeah,
present.
yeah, yeah.
.pem.
Locally that must be presented. Locally that must be
Oh,
presented.
okay, okay.
Okay, what is the key we created now? This key, right? 12th December, my key. 12th December, my key. So this is 12th December, my key dot pem. Okay, we are going to copy this file. Now actually this is there in downloads folder. So more options, copy and D drive, Terraform. Where is that folder? Here. Paste it over here. Let us validate. Okay, now it is success. Now directly we can apply, auto approve. Yeah, I have to comment this file also, inputs file. Now it is creating server, web server. Okay, now it is connecting to the server Ubuntu using Ubuntu and private key. Okay, it is connected. Now it will execute the script that we have written, Nginx script. Okay, here this is a public IP address. Public IP address we have given in the form of output, right? Take this and go to web browser and paste it over here. Are you seeing server is displayed here? So can you check it from your system, because this is public IP address, anyone can access this server. I have given this IP address in the chart window. From your side, if you can test it, okay, it is working from anywhere. 18.217.206.252. And tell me whether you are able to see this page. Welcome to Nginx page. Okay, right. You are able to see. Okay, yeah, this is about remote exec, guys. Tomorrow we will see how you can write file provisioner and local exec also. Okay, that is very simple. Okay, file means if you want to copy a file from your Terraform system to new server that Terraform creates, you can execute file. Local exec means just simply if you want to execute some command, some script in your local system where Terraform is running, you can use local exec. Okay, that we are going to implement tomorrow. Okay, so here till this point, you have any questions? Is everything clear, right? Whatever you have discussed today is very important. Okay, because provisioning is most important once servers are created. Okay, so if you have any questions, you can ask me. Otherwise, I will stop it for today. Tomorrow we meet again. Okay, to discuss other topics.
Okay, sure.
Okay, guys. Tomorrow we meet again. Thank you.
Thank you.